Okay, fine. So I think so. Good afternoon to everyone, students. So today's class we'll be trying to solve few questions. Okay. So before starting class, let me launch the technical poll. So ask your friends to join. Why we have very less number of students? They have only like 10 students who have joined the class. So I'm just launching the technical poll, guys. Today Pradeep sir is having some work, so he might be not joining. But we'll be solving few questions on current electricity. Sir, whether we can use pen up to the class starts. I don't know exactly about pen what you are telling, Namrata. So guys, am I audible properly? Is there any problem in hearing me? If there, please tell. Okay, okay. So I think so most of you. So okay, so yeah, okay, fine. So actually, how they can write? I didn't get it. Like students can write in the class. Like I have not drawn this line. How this line have came? Rakesh M. So who is this Rakesh M? He can draw the dots also. Sir, click on annotate. Okay, this annotate is for students. So where we will get out that option disable annotate for.
Mode and that mode you will see annotate disable annotate in 4 to 5.
Okay, fine. Now it's disabled, right? No one can write. Okay, okay, fine, fine, no problem. Okay, guys, so I'm just ending the poll. I think so most of you could able to hear me properly, and there is no problem in visible stream. Okay, so in today's class, we'll be trying to solve few questions only. Fine. You might have solved this kind of questions in your previous classes also. So we'll just try to revise. Okay. So I'll give you some time. Try to solve the questions. So the questions I'll try to make you explain, and then I'll try to give you the answers also. Fine. Okay. So our first question is fine. Why we have this half screen only? Okay. So try to solve this problem. First one. Okay. So if what you need to find the equivalent resistance. Find the equivalent resistance in first one. Hello, Karthik. So I think so you might be comfortable in solving these also. Everyone try to find the equivalent resistance and tell me what is the answer. What will be the equivalent resistance in the first one? Tell me first. There is no timer, right? Tell me, guys. Tell me the answer. What is the equivalent resistance for the first one? Try to write the problem. It is very easy. You have learned your current electricity chapter. So now we are expecting from you ki you try to solve such type of questions. And these are basic problems. These just make your concept boost. Okay, so you can expect such type of questions in JEE and NEET based on this. Don't expect same questions. because same question will never come in JWA. This type of question you have also solved in your class 10 also, right? So based on these concepts, guys, use the chat to discuss with me. Like if you wanna say something to me, use the chat, guys. So first concept is based on which concept? Can anyone tell me? Why nobody is answering? Is this too much tough? Guys, is this too much? Not more students would respond. Okay, okay. Fine, fine. Then usually don't read loud. Okay, okay. So for the first question that we have been provided is for equivalent resistance. We have been provided is for equivalent resistance. They are asking what is the equivalent resistance. So once we try to see this circuit, we'll try to find it out that. So we have to find equivalent resistance between A and B. We have to find the equivalent resistance between A and B. Now, when you see the points A and B, if you can clearly visible it, there are this is your A and this is your B, right? You have to find the equivalent resistance. How can you find the equivalent resistance? Simply draw A over here, okay? Then draw, then when you go and go, okay, Pradeep, okay, fine. So you can see that there is another point C which is coming in middle, right? So if you try to make it like if you try to draw it in a very proper way, you'll try to find out and you'll get to know that this will look like something like this. This is the resistance and this is your point C. This is the same point what you have drawn. This is your resistance R. So I'll try to write down resistance with some different color. And then from C, it has been connected to B again with some another resistance R, right? So this is your point B, and then from A you have been connected. So there is some another point D. If you take this point as D, you can take this point as D. So you can see that there is a distance from A to D, right? And from D to B, right? Can you see like this? And there is a resistance between C and D also, which is the middle resistance C and D. If you can see like this, you'll find it out. You'll find it out. This is looking like what? This is looking like your. So this is your resistance. This is your resistance. This is your resistance R. This is your resistance R. This is your resistance R. So it is just looking like Wheatstone bridge. Wheatstone bridge. At least the students, those who are there in Zoom, they can have a conversation with me using your chat. Okay, this is looking like Wheatstone bridge. So what is the how to solve a Wheatstone bridge? I think so you know, right? We have to neglect the middle resistance, right? Because the current will be, why we have to neglect the middle resistance? Because the current that is flowing from middle resistance will be zero. So you might have seen in your previous experiments or your school. So in your school there used to be have experiments, right? Galvanometer experiment. So you have seen that when you put the galvanometer here, the current that is flowing from here is zero. Since because the current is flowing from here is zero, we'll find it out key. Why the current is flowing out from zero? Why the current is flowing out from zero from this galvanometer? Because they have equal, because this is a balanced Wheatstone bridge. This is the balanced, BALANCED. This is balanced. And what is the meaning of balance? So if you call this as 1, if you call this as 1, this as 2, this as 2, this as 3, and this as 4. So when 1 by 2 is equal to 3 by 4, right? When 1 divided by 2 is equal to 3 divided by 4, that is in resistance, then we call this as a balanced Wheatstone bridge. And balanced Wheatstone bridge, what happened? The current, the current is equal to 0. And when current is equal to not flowing from middle, then it is only happening in balance. Make that in mind. So you might expect such type of question in unbalanced Wheatstone bridge, okay, where the current will be flowing from middle. Okay, so don't think always ki sir it is Wheatstone bridge, so always current will be there in middle. No, it is not always possible, right? So only when the condition is balanced, then only the current will be zero. If condition is not balanced, that means 1 by 2 is not equal to 3 by 4, then it is unbalanced Wheatstone bridge. Okay, so since here it is balanced, so what will write? How can you draw this? So simply you can make it like this is your A. From A you have this resistance, and then this is your C. Then you have the other resistance R, right? Then you have this resistance R and R, right? This is your point C, this is your point D, and this is your point A, B and A, right? And this is your R, this is your R. So what you can feel from here? So the other step will be direct. R plus R will become 2R. So it will become like this. Can you see? It will become like this. R plus R, since they are in series, it will become 2R. Correct, Karthik, correct. You have got it correct. Then this is your B, this is your. So this is very easy question actually. This type of question you have solved in class 9, right? Class 10, right? You have 2R. Now the equivalent distance between, they are in parallel. So what you can do is, since they are in parallel, so you can write to 1 by 2R, 1 by 2R. How much it will be getting? So you'll be getting 1 by 2R plus 1 by 2R will be equal to how much? So you'll be getting 2R by 2. So you'll be getting 1 by R, since this is 1 by R equivalent, which is equal to 1 by R equivalent. So R equivalent will be how much? So you'll be getting, this is A, this is B. Your R equivalent will be equal to R. This was an easy question, and here current was 0. But you can expect there is a change in question also. You can expect a change in question also from this. So I think so you might have understood that this is very easy. Okay. So what change in question that you can expect from here? The change in question. So I'm just erasing it. Okay. I'm just erasing it, guys. So the change in question that you can expect from here is, instead of what they will do, okay. Okay. So there's a change in question. What they can do, instead of writing this as R, they will give this is 2R. Okay. They will give this is 2R. Okay. So now if they will give this is 2R, this is not R. Now, if you try to draw the same circuit, you will find it out that it is something looking like this. It is looking same. The scenario will not change, but something different will change. The thing that will change is this will become R, this will become 2R, this will become R, this will become R, this will become R. This is A, this is B. Since this is C, so I'm writing here C, this is D, I'm writing here D. Right? Now it is an unbalanced Wheatstone bridge. Unbalanced Wheatstone bridge. Since it is an unbalanced Wheatstone bridge, you cannot say that in middle the current will be 0. Okay, so here the current will not be equal to 0. So if you want to solve such our problem, what you need to do, you need to use KVL or KCL. So first apply your you apply your normal current dividing rule. Okay, and then apply KVL. So if you want to find how much current is flowing, or if you want to, so you cannot directly tell what is the equivalent resistance over here, right? So this is, since it is an unbalanced resistance base, so you need to find KVL. So you need to divide the current. So suppose I current is going from here. So here I1 is going, right? So I'm changing the color, guys. So here I2 is going. Okay, here I2 is going. Okay, so here I1 is going, here I2 is going. Since the now I1, I2 are going like this, so what will be going? So instead of I2, you can write. So basically, you will be having of writing directly I2. So now from if you don't know, but I will be teaching you that instead of writing I2, write I minus I1. That will be easy way. Write I minus I1. Right? Apply the Kirchhoff's current rule. Right? Which says that key total current that is flowing from here should be equal. Right? So these are the branches. So if I1 is going in the above branch, the I minus I1 is going in the below branch. Right? If suppose from here the I1 came. Now what will happen? Now suppose if you have thought that here I2 is going, if you have thought here I2 is going, yeah, Kirchhoff junction rule. So what will happen? The downward will be what? So since I2 have came outside from I1, right? So here the left out part will be how much? Left out part will be I1 minus I2. I1 minus I2. Now you have I1 minus I2, and from here you have I minus I1, here I1 minus I2. So try to add it. They both are adding, right? You can see they both are adding. And they are going here. They're going in DB branch. So what you can write? I minus I1 plus I1 minus I2. So you can find that what you can find, I1 and I1 will get cancelled. You will be getting I minus I2. So in DB branch, in this resistance, you'll be having what current? You'll be having I minus I2. So this is the way you try to divide the current, and try to realize also. You can see that key here, from here I2 is coming, and from here I1 minus I2 is coming. So from here I is going. So which is, through this I can say that if I current is coming inside, then I current is going outside. And we can clarify ourselves that okay, whatever the current division that I have done by myself is correct, and I have not went anywhere wrong. Okay. And once you got all the currents, you can apply in any loop. Like you can apply KVL in A C D loop, A C B D loop, A C B D A loop, right? B D. Okay, and you can apply KVL in A C D A loop. You can apply KVL in C D B C loop. So you have these three kinds of loop. Over here you can apply KVL, and you can, yeah, conservation of energy also. Correct. So you can apply KVL and you can get the details. Okay. So they might find, they might ask you that. So what they, some in some problems they ask you like this. So they will add one resistance from outside. They'll add one resistance from outside, and they'll ask that key, how much is the how much is this resistance? Okay, how much is this resistance? How much is this R equivalent? So if they ask you like how much is this R equivalent or how much is this resistance, you have to do the KVL and you have to find all the current, and whatever the current that is going from here and whatever the voltage that is present, you have to find in the backward way. So you have such type of problems in your modules. If you know, I think so everyone knows about the module. Try to solve questions from module. Okay. Okay. So this is one of the best type of questions and one of the lengthier type of question. And this is the way of solving them. So suppose in JW, if you have trying to give JW, right, or need, suppose, so if you can find, they will take the same concept, the concept will be same, but they will try to solve, change the question type, right? They can add something different. Okay, they can add something really different in order to make a different type of question, but the concept will be same. That is important. Okay, that is more important. Okay guys, so I'm removing it. Let us try to solve the second one. And so I'm giving you 1 minute time. Try to solve the guys second one problem, that is find the equivalent resistance between, find the equivalent between, equivalent resistance between C and D. You have to find the equivalent resistance between C and D, right? So how can you try it? So try to find it out. If you can see the problem properly, you try to write it down in your notebook and try to find it out. How can you find the equivalent resistance between C and D, between these and this point they're asking? So always whenever you try to see such type of question, try to hold this point. Suppose this is your hand, this is your hand. Try to see like this as the learning, then try to elaborate it. Now you'll try to think something. You will get in some idea. We imagine the main important thing. So what you can find actually from C and D. So I'll give you like 30 seconds time. Try it out. You can think. It is not that much tough. It is easy. Just need to think. It is looking like something. If you can think, it is really easy. These are branches. These are branches. These are branches. Okay, branches. You know, I think so, right? So I'll give you an idea how to visualize it, because visualization is the important parameter in current electricity. If you cannot visualize the stuffs, you will find it really tough. So see, this is C my, this is my D, right? I can see that from C to D, I have one resistance. So from C to D, I have one resistance. I have drawn one resistance, which is my resistance R. Okay, this is my point C, this is my point D. Fine. And can you see the above one, how it is looking like the above one part? So if you can find it out, ki above one part is looking like something different, right? Is it looking like something like this? Can you see? Is it looking something like this? Is it looking like Wheatstone Bridge? Yeah, fine. Yeah, correct, Nikita. It is like a Wheatstone bridge with an external resistance, right? So it is looking like a Wheatstone bridge and it is having an external resistance, right? So you can see that this has been connected, right? This is R, this is R, this is R, this is R, this is R. Since it is the upper our part is looking like a Wheatstone base, so this will be neglected. So the resistance of our part will be how much? The resistance of our part was going to come as how much? Resistance of our part was going to come as R only, right? So it is R only, the R equivalent. And this is C and this is D. And from C to D, the downward is resistance R. So R equivalent between C and D is how much? Yeah, correct. So R equivalent will be nothing but R by 2, R by 2, which is your answer. Good, guys, good. So this is just a common way. Okay, we'll try to solve another problem. Fine. Okay. So mm, this is a type of problem which is based on. I'm not going to tell which type it is based, but you can try this problem right now. So I'll give you like 1.5 minute, 2 minutes time. Try to solve this problem. If you get the answer, Karthik, Nikita, and other students try to participate it. We have like 28 students in our class. This is like good number, 24 students actually. These are some few good level of questions. Okay. So and those students who have not switched on your mic, please switch on your mic, guys. Good like type of question, and these will help you to increase the concept. So try to solve this problem. These questions are from your module only, guys. If you are good enough to solve the module, you're good enough to easily compete with other JEE mains NEET examinations. Fine. Okay. So I'll give you just 2 minutes. I'll try to make you understand the problem. So the problem saying that there is a circuit showing in the adjoining figure. They have given the resistance R1, R2, and they have given two capacitors also. Okay. Now they're asking there is a EMF that has been put it over there, right? There is a voltage has been put it over there, right? Which they have given as E, and they have given you the polarity plus and minus. Fine. If they have not given, you could have find it out. Now they're asking calculate the charge on each capacitor. They're asking how much charge has been present in each capacitor. They're asking charge, how much is the charge in the capacitor, and identify the positive plate on each capacitor. So which plate is positive? Is this plate is positive or downward plate is positive? They're asking you that, right? In steady state. So this is the most important factor. Steady state. So what happened in steady state, right? So what happened in steady state? Steady state means what? Right? So what exactly happened with capacitors in steady state? So this you need to keep in mind. So I'm giving you just guys 2 minutes. Try to solve this problem. It is not a very tough problem, but this type of problem is really good. If anyone gets the answer, just tell me the answer in the chat. I'll be there. Holding. Okay. Okay. So basically what happened in steady state is, I think so if you don't know, steady state. Okay. So what exactly Q1 is? Okay. So what happened in steady state, you will get to know that, yeah, correct. Correct, Karthik, correct. You got it correct. You got it correct. So in steady state means you can understand that capacitor capacitor is fully charged. Capacitor is fully charged. Fully charged means what you can see. Once capacitor is fully charged, and you can say that there is no current flowing from capacitor. Flowing from capacitor. So you will think, sir, there is no current flowing capacitor, then how the charge? Yeah, high capacity. Yeah, reached is high. Correct, correct, correct. Correct, Karthik. You have got it. Correct answer. The answer that you have got is correct. Okay. Now, once the capacitor is fully charged, how you will take the capacitors? How you will try to approach such type of problems? So such type of problems, first check it out that what they have given, right? So since they, yeah, correct, correct, Bharat. So since capacitor is fully charged, there is no current flowing. Now you can think from here, ki, the capacitor have all the charges has been stored. So what you can think, that charge will be constant. But you can say that charge will be constant in capacitor. It is not कि few charge is degrading. Constant in capacitor. So how I'll try to approach such type of problem? How to approach, sir? So in order to approach, so they're asking the first of all they're asking two things. First of all, they're asking ki how much is the charge. Second thing, they're asking which plate is positive or negative. Okay. So whenever you get such a problem, you don't think like let us start from single one. Okay. See, mm, in such a, first draw your diagram. Draw your diagram properly. Okay. So you have drawn your diagram. Suppose this is your diagram that you have drawn. This is resistance R2. This has been connected over here. Okay, and here you will be having another capacitor. Fine, fine. So this is your E they have given. This is R1. This is your R2. This is C1, and this is a C2. So in order to approach such a problem, first try to divide the current. First try to divide the current. Okay, as per your idea, divide the current. Okay, so suppose this is your positive plate, this is your negative plate. So I'm expecting that current is flowing from here. Okay, suppose I have been flown from here. So I current have been took out from here. Okay, so here we have reached over here. I current have been went over here. Now from here also I current went out. Okay, fine. Am I correct? Fine, right? Now there is no resistance over here, no resistance here. So here also I current went out. You can see aram se ki here also I current went out. Here also I current went out, and then I current have came back. Okay, fine. So this I have told that this is negative, this is positive. Okay, so I have divided the current with respect to myself. Okay, since here the I current is coming, so I can tell that let me take this. This is positive plate, this is negative plate. This is just I'm taking reference. Okay, I can be incorrect also. This is just I'm taking reference. I could be incorrect. So if I will be incorrect, I will be getting the negative sign. If I'm correct, I will be getting the positive sign. Okay. So if you will think, sir, how on the starting only I should get positive. So it is not like that. You can choose any direction. Choose this as positive, negative. Choose this as positive. Don't worry about from the direction. Any plate in starting, choose positive or negative. Okay, so this is just the assumption you are trying to do. Okay, and then you can choose this as a positive and this as negative. No problem ki whichever you are choosing positive or negative. Okay, just choose any place positive or negative. Okay, so this is the initial step that you used to do. They're taking this plate is having charge Q1, this plate is having charge Q2. Fine, let me change the color. Okay, fine. Okay, so once you have tried to divide the current, and also try to make the plates which place you have to make positive or which plate you want to make negative. Now the second step, try to find what you don't know. So you don't know charge, right? And you don't know current, right? So charge, you don't know charge and you don't know current. So first try, can you find the current or not? Can you find the current or not? So if you name the loop, if you try to name the loop, so let me try A, B, C, D, E, F, G, H. So in the loop A, C, sorry, A, B, C, D, E, F, G, A. So in the outer loop, can you apply KVL? Can you apply KVL in the outer loop? Yes, you can apply. So once you start going to start from here, so what all things you will be getting? So I'm writing we are applying Kirchhoff's voltage law in outer loop. Outer loop. This is very general concept. Like this also only you need to think. So in outer loop, if you try to use it, what you will find? You will find it out. Okay, you are going from here. So once when you are going towards the direction and current is also there. So what should I write? Shall I write plus I R1? So we have two types of sign convention, right? So I use such a sign convention in which when we are going from outside the plate, so if you are going outside the positive plate of this, I'll write plus E. Plus E. Since I am coming outside of the plate, now I'm going towards the direction, towards the current direction. So what I'll write? I'll write minus I into R1. Am I correct, guys? Is this fine? Right? Then we are going, then we can say that, okay, I'm going towards the current direction only. So what should I write? I should write minus I into R2. Then we are coming back and again we are coming back to A. So this, in this loop, only these things are there. So this should be equal to what? This should be equal to 0. So in a closed loop, so since it is a closed loop, in a closed loop, the Kirchhoff's voltage law say what? It should be equal to 0, right? So if you'll try to find it out, how much you'll be getting? You'll be getting I will be equal to how much? E divided by R1 plus R2. We'll be getting this as a I. So how much will be the value that you'll be getting? The value that you'll be getting equal to E value is how much? E value they have given. See, they have given you in the question. E value as 6 volt. So you can write 6 by R1 value they have given as how much? 1 ohm and 2 ohm. So 1 plus 2. So how much you'll be getting? You'll be getting 6 by 2, that is 2 ampere. So the current that is flowing outside the branches of the circuit is how much? 2 ampere, right? Once you have finded out the current, can you find out the charge? Can you find out charge? So for charge, it is very easy, right? Go in this loop, right? And go in this loop. It is very easy for finding charge. Or instead of going in this loop, so instead of going in this second loop, so suppose this is your first loop, this is your second loop, and this is your third loop. So it is very easy. So this you need to define from yourself, or this comes from practice only. So see, if you try to go in second loop, now you will be have to face two capacitor. You have to face two capacitor in second loop, right? C1 and C2. But if you try to use the third loop, you only have to face only one capacitor, that is C2. And if you try to go in first loop, you only have to one capacitor, that is C1. So it is better that if you use first loop and third loop, right? Third loop and first loop, right? So if let me go in the first loop. So in the first loop, what I'm writing, I'm trying to write it down. What? In the first loop that I'm trying to write it down. So what shall I write? So I'm going towards the current, right? So I will write minus how much? Minus I into R1. Minus I into R1, right? And then I'm trying to getting out from the, so I'm going like this, I'm trying to get out from the negative part of the capacitor. This I have assumed, right? This I have assumed. So what I'll write? Minus, how much should I write? I should write minus Q1 by C1, Q1 by C1. And in this closed loop, this should be equal to how much? This should be equal to 0, right? So how much you'll be getting? You'll be getting the charge. You need to find Q1, right? So you'll be getting minus I into R1 should be equal to Q1 by C1. So you'll be getting Q1 is equal to minus I R1 C1. So how much is it? Minus I R1 C1. So I value is 2, R1 value is 1, C1 value they have given is how much microfarad? 1 microfarad. 1 microfarad. So how much you'll be getting? Will be got as a minus 2 microfarad. So what is the meaning of this minus sign, guys? What is the meaning of this minus sign? Can you tell me? What does this minus sign is telling? So this minus sign is telling is that whatever sign that we have took is wrong. Direction should be opposite. That means this downward side plate should be positive and upward side should be negative, right? that we have assumed, right? Whatever you have assumed is you have assumed wrong. You have to go opposite. Okay, so don't think of from starting only that whatever I'm thinking is correct only. You might thinking wrong, but you how much is the answer you are getting? If you're getting some minus, that will lead to get you the correct answer. Okay. Similarly, if you apply the loop, so can you apply? So if you apply, so the answer, the first answer is, so I'm writing down the answers here. See it, guys. Okay. So how much is Q1, guys? So you have got your Q1 is nothing but minus 2 microfarad. Minus 2 microfarad. Fine. Okay. So if you write plus 2 microfarad, that means you could change the sign. Now for Q2, for Q2, if you try to go in loop 2, it will be tough, right? Then you need to go in loop number 3. So if you write loop number 3, so try to apply KVL in loop number 3 like this, right? So you are coming outside, so you have the voltage. Yeah, micro, I have told micro only. So it is microcoulomb only, microfarad. Okay, yeah. Fine. It will be microcoulomb. Just since it is charged, right? It will be microcoulomb. Fine, right? Okay. Now in loop number 3, how can you apply? So let us try to apply. So we are going out from the positive side of the plate. Since I am going on positive side, easily I can write plus E should be equal to. Then I'm coming here, nothing is there. I'm coming out from the negative side. So what should I write? I should write minus Q1 Q2 by C2 should be equal to how much? Should be equal to 0, right? Minus Q2 by C2 should be equal to 0. So how much you'll be getting? You'll be getting very easy. You'll be getting Q2 will be equal to C2 into E, right? So C2 value is how much? 2 microfarad multiplied by E value is how much? 6. So you'll be getting 12 microcoulomb, right? And you'll be getting plus that. What is the meaning of plus? You are getting plus. What is the meaning of plus, guys? So plus meaning that whatever direction that you have choose is the correct direction. Right? So this is the way how you should approach the problem. So they have provided you the steady state, right? That's why you have took current as 0 and you have not changed. So they might have give you that instead of steady state, they can give you other type also. Like they can go and tell you that key instead of steady state, they can say key for zero at when time t equal to 0 or when time t equal to 0 plus and when time t equal to 0 minus. So they can say like that. Right, so I'm writing it down. Q2 is equal to 12 plus 12 microcoulomb. Right, so instead of steady state is a state in which capacitor is maximum charge. Suppose if they write instead of steady state, they write when t is equal to 0. So at time t equal to 0, what exactly happen is capacitor have not charged. Right, it is discharged. Right. So and they can write t when t is equal to 0 plus. So 0 plus meaning is just now capacitor have started to charging. Okay. And when there is something called t is equal to 0 minus, that I think so will be not here. Right. Okay, fine. So you might have understood this type of problem, how to this is type of RC network problem. Okay, there are other types of problem also. You can expect you can solve this type of problems from a module. Okay, so we'll try to solve another problem, guys. Let us move ahead to another problem. Fine. Okay. So this is easy problem. You just need to be confident to solve that. So what in this problem they're asking, determine the current in each branch, right? They're asking determine the current in each branch. So you need to divide the current in properly. Okay. So the biggest question that comes in mind, sir, from where we should start? So I'll give you like 1.5 minute. Try to solve this. Okay, if you get the answers, let me know. If you get the answers, let me know. Else, I'll be solving it for you. Okay, just let me know if you get the answers. Fast, fast, fast. It is not a very tough question. Very easy question. You need to understand the one basic concept from this question. Okay, from where you should start dividing the current. Which point should be the my startest point in order to divide the current, right? This you need to understand from this concept. So why I'm trying to solve this problem. Okay, so from a, yeah, correct. So I'll give you hint, okay, this problem done in class. Okay, Pradeep, so shall we do it again? Is there any problem? Yeah, so if this problem is done in class, guys, I think so you could do it faster. Yep. I get it. Fine, guys. So how you'll approach this? In order to approach this problem, see, first you try to see the voltage. How many voltages are there? You can see there is a 10 volt here, and you can see there is a 5 volt here, right? So there are two voltages. One is 10 volt, another is 5 volt. So whenever you see more than one voltage source, in a problem, if they ask you that divide the current or apply KVL or apply KCL, something like that, anything, if they ask you that, or you have to suppose in problem you have to divide the current. If you see more than one voltage source or more than one or two voltage source, what you exactly need to do is you need to start dividing the current from the higher voltage source. So the higher voltage source is 10 volt. You need to start dividing the current is higher. This is one of the major concept in current electricity. Higher voltage source. Okay, so start dividing the current from higher voltage source only. So suppose if I have written 15 volt here now, then you should not divide from 10 volt. You should start dividing voltage from 5 volt only, that 15 volt only. Okay, if you start, so if you have started solving the question, no problem. So if you have solved this problem in your class, fine, I'll change the problem, I'll change little bit problem. Okay, so now take this as 15 volt. So this is not 5 volt, this is 15 volt. Okay, so I'll write it in clear way so that now try to solve the problem. So if you try to divide it from 10 volt, you might get incorrect answer. Try to divide the current from 15 volt. So this is your 15 volt. I'm writing down. Okay, so I'm writing down. Take this as 15 volt. Take it as 15 volt. Okay, so try to take it as 15 volt. Now when this is your 15 volt, and if you try to divide your current from 10 volt, you might get incorrect answer or you might get incorrect concept. Okay, so always try to divide the current from the higher voltage. So the higher voltage is 15 volt. So this is your plus, this is your minus, right? So if you take, suppose I current is going from here, right? So when it come to this branch, I have assumed that I1 is coming downwards. I1 current comes downwards. So how much current is going here? Here the current that is going is I minus I1, right? How much current is going, that is going in branch AB is I minus I1. Okay. Now in branch AB, if I minus I1 current is going, so few students will get confused, sir, some current will go from here. Don't get worry from this smaller world. Don't neglect it. Think that there is nothing is there. Okay. Just neglect it. Nothing. Don't worry about it. So when you come to this point, you have I minus I1 current, right? And then you have two other branches. So suppose if I have thought that I2 current is going here, But I have thought IT current is going in this direction. Okay, so how much current will be going in this direction? Can anyone tell me? So I minus I1 is coming. So we have something like this. So suppose I2 is going in this direction, and from here I minus I1 is coming. So how much that is going here? The part that is going here is I minus I2, I1 minus I2. How much is going? I minus I1 minus I2. So the current that is going in AD branch is nothing but I minus I1 minus I2. Right? Now from here, see, from here I2 is going, and from here I1 is coming. So in CD branch, how much it will be? I1 plus I2. Right? In CD branch, you will be having I1 plus I2. Now from CD branch, I1 plus I2 is coming, and from here I minus I1 minus I2 is going. So how much will be here? So I1 and I2 will get cancelled. I will be coming back. If you are very careful in this type, doing the current division like this, you will be not doing any wrong concept, and you'll be easily able to use the KVL also. And instead of using like, so what many of you will do, what now I know what they will do, sir, I1 I2 I3 I4. So try to use as many less variable as you can, because this will help to solve the question faster. If you try to take I1 I2 I3 I4, now what will happen? Now if there are four variables, then you need to take four types of, if you, so suppose if you have two variables, you need two equations, right? Three variables need three equations. So if you have four variables, need four equations. Now you have like three variables. Well, what are those variables? You have you have I1, I1, and you have I2. You have only three variables. That means if you can easily write three equations, you can easily solve this problem, right? And all are interconnected. Fine. Have you understood this, guys? How to divide it? So again, I'm trying to write it down for you. Just last time revision. Okay. How to divide it? Just don't divide it in maximum number of variables. Try to divide it in minimum number of variables, because minimum number of variables need minimum number of equations, which will help you to solve the question in minimum amount of time. Just by taking maximum, you will think that writing is easy, but solving will be tough. Okay. Now again, I'm writing it down. Suppose you have to I1, I is coming from here, so I have took that I1 is going down, right? So I minus I1 will be here. So since I minus I1 is coming here, so we have two options. One is going here, one is over there. So suppose in this 10-volt line in AC, I have to I2 is going here. Okay, I have to I2 is going here. So here what will be going? I minus I1 minus I2 is going here. Now from here I2 is going, here I1 is coming, so here will be I1 plus I2. Very easy. Now I1 plus I2 is going down from CD, and here I minus I1 minus I2 is going down from AD. Both will get cancelled out. Only the term that is left out, that is going here, is I. And since the current I is going from here and current I is coming here, that means I am confident enough to say that, okay, fine, I have done my current division very perfectly. Okay, now once you have done with your current division, now you apply KVL or KCL. So you have how many loops? You have very types of, you have four loops actually. If you can see it clear, you have four loops actually here, right? Actually, you can solve this question by using I1, I2, I3, I4 also. But if you try to make it less loops, you'll be more confident, right? So what are all those four loops? One loop is, see, I'm writing down the loops. If you can see it, A, B, C, A. This is your first loop. Second loop is A, C, D, A. This is your second loop. Third loop is, so you have more than four loops actually. B, E, D, A. Sorry, B, D, E. Right? B, E, D, E. Use different loop. B, E, D, E. So this is your third loop. The fourth loop will be what? A, B, D, A. Right? Fifth loop will be what? A, B, E, D, A. Right? Are you guys, could you guys able to see it or not? So these are your four. Someone will tell, sir, can we take A, C, D, E, B, A. You cannot take this loop. This is not a loop. Okay, because loop should be closed, right? This is looking like closed, but there is something coming in middle. So you can take this is also, but you'll be finding difficult because you have not learned such type of loops. Okay, so you can take this loop also, and you can go further, more complex. It will become more complex. Okay, so these are your very easy loops which you can take, and you can go more internal also. If you can see these loops also, A, C, D, E, A, B, then it is very good that you are understanding the problem. Okay, so you can stay A, C, B, E, D, C. So these are also your loops actually, but you might have not thought about such type of loops, right? So it is not you cannot solve using these loops. You can solve the problems using these loops. But see, you have to, how many variables? You have three variables. You need at least three loop, right? If you have three variables, three loop, you can easily solve the problem. You have more than five loops, right? Okay. So now let us try to take the easier loops. So I can see that the first loop is a easier loop. So let me take three loops. Okay. So let me number it: 1, 2, 3, 4, 5. Okay. So let me take the BE, right? Let me take the third loop. Third loop. So from third loop, I'm applying KVL. So everywhere I'm applying KVL, right? I'm trying to write down the equations. So it is very easy writing down the equations. You need to be confident enough, right? So in the third loop, it is going from B, E. So from B to E you are going. Then from E to D you are going. So you are entering from the positive side of the battery and you're going out from the negative side of the battery. So you should write minus 15 volt. Simple, right? Because you're going out from the negative BE, then D, right? So B, not BC. So some you actually your one, yeah, their C is missing. Your one friend is saying, sir, B, C, D, E. B, E, D, C, B. Okay. So what I have written is a bit ulta, looking like ulta, right? Fine. So you can go opposite also, no problem. Actually, Nikshant, you can go opposite also. Like you don't have to go like towards the current direction only. You can go opposite also. So you can take B, E, D, C, B. You can take this, like it is same thing, right? You can go opposite. You don't have to always go. Okay. So you can take any time, either clockwise, anti-clockwise, depends upon you. Okay, Nikshant. Diksha. Fine. So minus 15 volt. Then from E to D, there is nothing. There is nothing is there. From E to D, is there anything? No. There is no any stuff. Right. From E to D, there is no anything. So you don't have to write anything. Right. Now from D to C. So since it is B, E, D, C, B. So from B to E, we have something. So I have written from E to D, they don't have anything. Then from D to C, from D to C, what we have here? We are going opposite to the direction of current. Since we are going opposite to the direction, so shall we write positive or negative? We should write plus. We should write plus. Plus how much? Plus 2 multiplied by I1 plus I2. Right? We are going opposite to the direction of current. Right? Now from C to B, again we are going opposite to the direction of current, what we have assumed. Right? So we'll write plus 2 into I1. This should be equal to how much? This should be equal to 0 because it is a closed loop. We have applied KVL. This is your first equation. So after solving the equation, how much you will be getting? See, you will be getting 4I1. So first equation you will be getting 4I1 plus 2I2 should be equal to 15 volt, right? So see, this is one of the easiest equations. See, in this equation also have one more important thing, that this equation does not contain I. So we have three variables, right? I, comma, I1, comma, I2, right? So if this equation does not contain I, that means you are more satisfied from this equation. This will help you a lot. Okay. Okay. Fine. So let us try to use the other loop. Okay. So the other loop is, let me try to take the first loop. Okay. Let's try to write the KVL for first loop. First loop is A, B, C, A, right? So from A to B, we are going opposite to the direction of current. So we'll write 4 plus 4 multiplied by I minus I1, right? Then we are going from B to C. Oh, we are going towards the current. So we'll write minus 2I1, right? So towards the current, we'll write minus. Then from C to D, we have very things. We have a battery also and we have a resistance also. The for resistance, we are going opposite to the direction. So we'll write plus 1 into I2, right? And then we are coming out from the positive terminal of the battery. What is happening? So battery does not affect, right? This battery is not affecting due to the current, right? So we are coming from the positive terminal of battery. So I'll write plus 10. And this whole should be equal to how much? This whole should be equal to 0. This whole should be equal to 0, right? So from here you will be getting your second equation. How much will be second equation? So if you try to solve it out, you'll be getting, see, minus 4I1 minus 2I1. You'll be getting minus 6I1. Then you'll be getting plus I2. Then you'll be getting plus 4I should be equal to minus 10. So you can write from here that 6I1 minus I2 minus 4I should be equal to 10, right? This is your second equation. This is your second equation. This is your first equation, right? And now from the your second loop, are you guys getting? So this is looking complex, but is it not complex? This is a way, but you should do this in a faster way. What happened now? If you go in a faster way, sometimes you do mistakes in writing that. So go like in that place only which you feel comfortable. So A, C, D, A. From A to C, you are coming out from the negative terminal of battery, so I'll write minus 10. From you are going towards the current, so I'll write minus I2. Then you are going from C to D, you are going towards the current, then you will write minus 2 into I1 plus I2, right? Then you are going from D to A, that you are going opposite to the direction of current, then you will write plus 4 into I minus I1 minus I2. This should be equal to how much? This should be equal to 0. So if you try to solve this, you will be getting how much? See here minus 2 I1 plus I2, here plus 4. So it will become how much? Here also you have minus, if you take minus and outside common, so you'll be getting minus 10 minus I2. If you try to solve it, you'll be getting so let me write it down. So let me bring 10 over there, right? Okay. So how much you'll be getting? You'll be getting C. We have minus 2I1 and we have minus 4I1. So you have minus 6I1, right? Then for I2, minus 2I2, minus 4I2, minus 6 and minus, we have minus 7I2. Okay. And then we have plus 4I should be equal to 10. This is your third equation. Third equation. So you have three equations and you have three variables. So can you able to solve it? You have three equations and you have three variables. So I think so this you could solve it. I'll be not solving this, but I think so this you could solve it. So this is the major part that you need to understand it. Okay. So and even for examination, use this technique and go faster. But I'm trying just to make you explain. I was going in slower pace. But for your understanding, first step, write the equation, divide the current in a very proper way, like divide the current as much as you can. Second step, write the KVL in a like for whichever equation. So don't just write the KVL in a very hurry thing. Okay, I know KVL, I am very confident in writing the KVL, so I'll write any KVL. So see, visualize, think which will be easy and which will give you the answer fast. Okay, so just don't like go in rush and try to solve the KVL. Okay, and third thing, once you write down the KVL, here the major mistakes come just due to your mathematical calculation, and you do lots of mistakes in mathematical. You try to solve this in a very hurry way and you get wrong answer. Okay, so try to solve this in a very gentle way and get the correct answer. So I think so from here you can easily calculate I1, I2 and I value. You have three equations, three variable, you can easily calculate. Okay, fine. or if you don't know how to calculate this, I can tell you the easy way will be matrix. You can use matrix technique to solve it. If you don't know matrix or determinant, substitution is the other way, which is lengthier way, but you will get the answer. So even in substitution also, just sir, we have sign convention according to battery of largest, sir, no sir. Yeah, so you have the sign convention with respect to the largest battery cell value. So whichever the voltage source will be having, so we call this as a voltage source. So whichever voltage source is having the highest volt value, with respect to then only try to divide the current. Okay, then it will be, you will be getting all the values and currents in a proper way. That is one of the technique actually we use in current electricity. Yeah, fine. No, sir. Yeah. So substitution rule. So see, you have I1, I2. You don't have I here, but you have I1, I2, I here, I1, I2, I here. Do what? You try to put any I. Take I from here. Take I here from here and put in both the equations. Put in both the equations. Then you will be having I2 and I here. You will be having I2 and I here. Then you can solve these two equations. Find I2 and I value. And once you get I2 and I value, you can easily put it in back here. You'll get I1 value. Once you get I1, I2 value, you can get it back here. Sir, and sir, other battery may change its convention. No, 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 no. Yeah, if you use the other battery now, you may get the current direction opposite, or you may get the incorrect answer. Okay, so this is the general technique actually. General technique actually. It is not always. This is a general technique. If you don't know how from where to divide the current, you take the from the highest battery source. That is a general technique actually. Okay, even if you can divide the current from 10 volt also, but what will happen, okay, you might get incorrect answer. Okay, this is the general technique. Got it, Nithanka, have you got it? Fine. So I'll try to solve one last problem, then we'll wind up for today, guys. If anyone is having any doubt. So this is very common type of question. Don't expect in JW or NEET, but you can expect such type of problems in our other competitive exams. Right? They used to ask such type of question. Okay. So what they are asking, the see, first read the question. Okay, they're asking the circuit shown in the adjoining figure. Sir, in the given figure, the sign of smallest battery sign changed when we took the sign convention of no, 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 it will not change. It will not change actually. See, here we have taken positive only, have taken negative only. It will not change only. Yeah, the current direction has been changed. So don't worry from the current direction. Yeah. Don't worry from the current direction. That current direction is with respect to the higher battery cell. So don't worry from the current direction. Okay. So once you try to find, you might get that K, this I2 value is opposite. You might get the IT value as negative. Okay, Nitanka. So we have changed the problem actually, right? We have took 15 volt, right? Got it now? So don't worry from the current direction from the other battery cell. Just worry from the highest battery cell, you are taking the proper current direction. That is important. So if you are taking this battery as your priority, so everything should be this battery priority only. Other battery priority should not. So you might be thinking, sir, see from positive side, the current should go outside. So why it is coming inside, right? So it is because the battery cell that you have took priority is 15 volt. You have not took the battery cell 10 volt as priority. Okay, so it's not getting affected from it. All the things you are calculating with respect to 15 volt. Okay, fine. Okay, guys. So in such type of problems, so they are asking in the circuit shown in the adjoining figure, the current through. So see, they're asking you in the question in a very different way. They're not asking you from particular thing. They're writing that the 8 ohm left resistor, the 8 ohm right resistor, right? So either left or right. The 4 ohm resistor is the 4 ohm resistor. So we have only 4 ohm resistor. So they're giving you three different kind of choice, right? That means from such type of questions, they're expecting you to find the current from all the branches. So if you want to find the current from all the branches, you try to make it, so try to solve it the current for all the branches. So current division is very important in such type of problem. Okay, current division is important, and you cannot like find for you cannot so such type of problems be try to find current for all branches, all branches. Okay, so what you will do, I know what you will do. You will try to find very hard and you will give your 100%. You wasted your 3 minutes and you try to find for 8 resistance, and you will get to know that you 8 ohm resistance is not having 0.25 only. So these both options are incorrect, and then you will have wasted your time. Then you have to find the current for 4 ohm. So try to find the current for all branches, which is the easiest way, and then check out which of the options is correct, and then directly kick it and go outside, go back to net problem. So this is the easiest way of solving such type of problem, right? Because you will be having like 1 minute or 1.5 minute or 2 minutes time only for solving a particular question. Okay, so once you try to solve the question, you can easily find the equivalent resistance, right? So first find the total current. So you can easily find the total current that is going out from there, 8 volt. So total current that is coming out, you can, so 4 ohm plus 4 ohm plus 4 ohm. How much will be? It will be 8 ohm, right? So 8 ohm parallel with 8 ohm will be how much? 4 ohm. Then 4 ohm plus 4 ohm plus 2 ohm, 8 ohm. 8 ohm parallel with 8 ohm is how much? 4 ohm. So you'll be getting something like this. You'll be getting something like this, right? So you'll be getting this as 8 ohm and you'll be getting this as 8 volt. So about this 8 ohm, they are not asking. First of all, this is the equivalent 8 ohm. Okay, then they have not asked about this. They have asked about this 8 ohm and this 8 ohm. Okay, so keep that in mind. So you think that you have made this 8 ohm and you try to get the answer and then made it tick, then that is incorrect. So how much you'll be getting the current? The current that you'll be getting, so V equal to IR. So you'll be getting I is equal to nothing but V by R. V value is 8 by 8. So you'll be getting 1 ampere. So 1 ampere is what? 1 ampere is the total amount of current that is coming outside from 8 volt. Okay. 1 ampere is the total amount of current that is coming outside from 8 volt. Okay. Fine. So this is the total amount of current that is coming outside. Okay. Now what you need to do, you try to do the current division. Basic thing. Once you know. So once you have done this, this is very easy. First step. Second step is do the current division in a faster way. So how you can do the current division in a faster way? Write it down. So you can easily write. You can easily write. So instead of taking 1 ohm now only, take this as I. So suppose I current is going from here. I current is going from here. Here I current will come. Here when it will come. So I have thought that the downward side I1 is going. So this side I2 will, I minus I1 will go. Right? In downward side, if I1 is going, then this side I minus I1 will go. Similarly, if I take that in downward side I2 is going, then in this side I minus I1 minus I2 will be going. I minus I1 minus I2 will be going. So from here I1 minus I2 is coming and I2 is going. So we'll be having how much? I minus I1 will be here. Right? Then you will be having I minus I1, you'll be getting back I. Right? So you know the value of I. I value is how much you got? Just now you have got I value is nothing but 1 ampere. Just now you have tried to find I value. So once you got the I value, what you can do, guys, you can easily apply the KVL, right? So will be any profit in applying the KVL in first loop? So this is your first loop. Will be any profit in applying the KVL in first loop? Yes, there will be profit. What profit you will be getting? You will be getting to know that how much is current that is there in, how much is the current that is there in A2, right? You will be getting the value of I1. So try to find the value of I1 from first one. So if you try to use the current in in clockwise direction, how much you will get? So going from here, that is plus and minus. So I'll write plus 8 volt. Then you are going towards the direction of current. So I'll write minus 2 into I, right? Then you are going towards the direction of current. Then you're writing minus 8 into I1. Then you're going back towards the direction, and you'll write? You'll write minus 2 into I should be equal to how much? Should be equal to 0, right? Should be equal to 0. So how much you'll be getting? You'll be getting 8 volt. You'll be getting minus 2 minus 2. How much you'll be getting? Minus 4 into I value is 1. Minus 4 minus 8 into I1 should be equal to 0. So you'll be getting 4 volts should be equal to I1. So 8 I1. So I1 value, how much you'll be getting? I1 will be 4 by 8. So you'll be getting 1 by 2, right? It will be 0.5. So you are pakka from here ki this option is incorrect. I1 value, that is left side 8 ohm resistance, is not having the but this side, this I1 value is 8 point the left hand side. So now you know the value of I, you know the value of I1 also, that is 0.5, right? Is the incorrect answer. Okay, once you have got the I1, you can easily apply in second loop. So apply in second loop, right? From second loop, everything will be clear. You don't have to think too much. Second loop is the will be the last loop. So in second loop, or you can use this. So if you're writing A, B, C, D, so you can write A, B, C, D in the outer loop also, right? You can apply in the outer loop also. So I'll ask you to, I'll prefer you to use the second loop because that will be more easy. So if you try to apply in the second loop, what you'll write? You'll try to write minus 2 into I minus I1. Then you'll write minus 8 into I2. Then you'll write how much? Minus into I2. Then you'll write minus 2 into I minus I1 because you are going towards the current. And here you are going opposite towards the current, right? Sir, how you took as 1 ampere? Nikanta, see, just now it's solved, right? Okay, I'll show you, Nikanta. I took the 1 ampere. I minus I1 and then it is plus 8 into I1 should be equal to 0. So I will show you how I have took the 8 ohm. Nikanta, watch it out here carefully. If you try to find the equivalent resistance, how much you'll get? If you try to find the equivalent resistance, how much you'll get? See, this is a 2 ohm. So this is a 2 ohm, here also a 2 ohm, and this is 8 ohm, right? And this is a 2 ohm, and this is also your 2 ohm, and this is your 8 ohm. Fine, right? Now, what is the equivalent resistance of? So equivalent resistance here will be what? 2 ohm plus 2 ohm plus 4 ohm plus 2 ohm. It is 8 ohm. So it will be like this, right? 8 ohm. Now 8 ohm is parallel with 8 ohm. So how much you'll be getting? Again, you will be getting same stuff. Right, again you'll be getting same stuff. You'll be getting 2 ohm, you'll be getting this as 4 ohm, and you'll be getting this as 2 ohm, right? 2 ohm, 8 ohm, 2 ohm. Now this is again series. This is again in series. So 2 ohm plus 4 ohm plus 2 ohm, which is 8 ohm. So again it will try to solve it. How much you'll be getting? You'll be getting the same stuff. That is, you'll be getting 2 ohm and this 4 ohm, and then again you'll be getting 2 ohm. So 2 ohm, 4 ohm, 2 ohm, and this is 8 volt. So since you know, so how much will be the equivalent resistance? So equivalent resistance will be how much? Equivalent resistance will be, this will be your 8 volt, this will be your 8 ohm, and this will be your 8 volt. Have you got it now? Nikancha, have you got it? So we have V equal to IR, right? So I is nothing but V by R. So V is nothing but 8 and R is nothing but 8, right? R is the equivalent resistance. So it is 1 ampere. Have you got it? So 1 ampere is the current. 1 ampere is the current that is going out from it. So this you need to do in starting. So you get to know. So this is how you make your calculations easier actually. So you can do, if you cannot find, if you don't find this now, you need to write 3 equations, find 3 variables, and then solve the question, and it will become much more complex. So instead of going much more complex, make it clear as much as easy you can. So it is easy. So you can make it easy like this. Okay, fine. Now once you have wrote down the second equation, from second equation your whole answer you will get. So this I'm writing in very slow pace. You can write it in a very fast pace, and in mind only you can do all the stuffs, right? So you can write that there is minus 2 I1 I2 minus, so it will become minus 4 I minus I1. Okay, and then here minus 8 I2 and plus 8 I1. Okay, which is equal to 0. Okay, then we have minus 4 I minus. So you know the value of I, it is 1, I1 is 0.5. So whole value will be how much? Minus 4 into 0.5, right? Minus 8 I2 plus, it depends upon you how fast you do the calculation, right? Then this will become how much? My 4 minus 4, it will become 2, right? So this will come 4, it will become how much? 2, na? So 2 minus 2 plus 8 I1 is equal to 8 I2, right? So I1 value is 0.5. So it is minus 2 plus 4 is equal to 8 I2. So I2 value is how much? I2 value will be getting how much? 2 by 8, which is nothing but 1 by 4. So we'll be getting I2 value as 0.25. How much will be getting I2 value? I2 value is 0.25. Right. So I2 value, that is the current that is flowing from 8 ohm resistance is 0.25. Now if you want to cross check that whether I'm writing it correct or not, what you can see is from 4 ohm resistance. So from 4 ohm resistance, how much current is flowing? I minus I1 minus I2. So I is 1 minus 0.5 minus 0.25. How much it will be? So how much? 1 minus 0.7. We'll be getting 0.25. So how which all options will be getting correct? So we'll be getting option B and option D as your correct answer. That is from 8 ohm resistance 0.25, from the right 0.25 current is flowing, right? That is your I2, and then from your 4 ohm resistance 0.25 ampere is coming. Are you guys understanding? Is this understandable, guys? So this is one of the easy way to solve this such a problem. Else what you'll do, you'll make yourself in loop. You'll try to find this, and you will not able to. So this type of problem, eliminate the wrong answer first. Eliminate the wrong answer first, and then you'll be more comfortable in solving question. Okay. So anyone is having any doubt, guys? Else will be like we have last 10 minutes. I'm just launching the poll, guys. You just try to answer the poll, and else like we'll wind up for today. Okay. So next class we'll be having by your Pradeep sir only, and then you might be having few more questions on this, and expect the chapter test of this might be in coming Sunday. Okay, and try to solve questions from your module, guys. The module having really good number of questions. More focus on RC concept, because one question used to come from that concept. Okay, and mm, be confident in KVL, KCL, and these all things are really important. Anyone is having any doubt, just ask me in the chat, or like you can ask me if you're seeing in YouTube. You can ask me in the YouTube also, guys. Like it will be given to me if anyone is having any doubt. Okay, okay, guys. Okay, fine. So next class onwards, you will be given to undertaken by Vishal sir. He's a very good physics teacher, and you might be understanding these all concepts in a very good way. Okay. Okay, okay, Pradeep, got to know, got to know. Fine, fine. So anyone is no one is having any doubt? So these questions are from your model only, guys. If you don't have module, you can ask your subject teachers in the respective groups. They will prefer you, or yeah, they'll share you the links. So these are few easy way of solving these questions and solving few important questions. Okay, so never worry in check current actually, don't get worry from the direction what you are taking. Always take any direction and solve the problem. And if you get negative answer, suppose in this problem also, if we might get some negative answer, so we have got all the answers positive. Right? That means that we have made all the things in the proper correct direction. Okay. In this question only, if you have took the direction of current opposite, you might have got the incorrect answer. Incorrect answer means you might have got the incorrect the negative answer. That will help you to make you understand that you have to change your direction. Whatever direction you have to change your direction. Okay, guys, so no one is having any doubt, so we'll wind up for today, guys, and we'll soon meet you in next class. Okay, be prepared for next class, and then see you. Bye bye.